right, guys, so I'm gonna I'm recording the lesson for 2.5. Obviously, pause it whenever you need. Okay, so we are now moving into quadratics. So, I'm sorry, let me go back. 2.5 is on quadratic equations. And you should remember from Algebra 2 that for something to be quadratic, that means that the power is squared. So, 2x squared plus 5x minus 3 or, whatever. But the big thing about quadratics is that the highest power is the power of 2. So what we're going to be doing today is we're going to be solving these. So the first way that we're going to solve is solve by factoring. Okay, and we have gone through factoring. So a lot of what we're doing right now isn't anything big, okay? But in order to be able to solve by factoring, you have to know what the zero product property is. Okay, so the zero product property says, I can't spell. That probably isn't even right. It says that if I have two numbers, A and B, and I multiply those two numbers, and the answer is 0, so if A times B is 0, then, oops, that's not it. Either A has to be 0 or B has to be 0. Okay, so what this is going to allow us to do is it's going to allow us to have like x plus 5, 2x plus 9 equal to 0. And we're going to be able to take x plus 5 and set it equal to 0. And 2x plus 9 and set it equal to 0. And then we can solve for x here. And we can solve for x over here. Okay? So that's if we are solving by factoring. Now, there's a lot more into that. Okay? So, while we're doing this, okay, to solve by factoring, we're going to do a couple of steps. So your first step in solving by factoring is to factor, okay? Whether that's using GCF, goal numbers, AC method, grouping, whatever. Okay, factor. Set your factors equal to 0. And then step 3 is to solve. So solve, set your factors equal to 0. I'm sorry, factor, set your factors equal to 0, and solve. I'm sorry, I'm so tired right now. I'm really struggling. Okay, so we are going to do an example. Okay. This is our first example. And our first example says x squared, that's not a square, plus x minus 6 equals 0. And this is solved by factoring because there's no other way to solve that. So we need to factor this down. So since our x squared term, since it has 3 terms and the x squared term doesn't have anything in front of it, we're going to use goal numbers. So the goal is I want to multiply two things to -6, but add to 1. So it's going to be -2 and 3, or 2 and -3. If I add these two, I get 1. If I add these, I get -1. So it's these two. So I get x minus 2, x plus 3 equals 0. So we have factored now. Now we're going to take our two factors, so x minus 2 and x plus 3, and we're going to set them equal to 0. And now we're going to solve. So this one I add 2 to both sides, so I get x equals 2. On this one I subtract 3, so x equals -3. So x equals 2 and x equals -3. And you're done. Okay. So in our second example, they have given us 4x squared plus 15x, plus 9 equals 0. Okay, so when you have a coefficient bigger than 1 on the front, first thing you need to check for is a GCF. So 4, 15, and 9 do not have a GCF. So then the next thing you need to ask yourself, since we have 3 terms and we have a number in front of that, is what method are you going to use? It should be either the AC method or the box method. So when I graded your guys' first chapter test, most of you did not use the box, so I'm just going to go ahead and go with the AC method. So for the AC method, you multiply A times C, and 4 times 9 is 36, I think. Yeah, it's 36, x squared. So what I want is I want two things that multiply to 36x squared, but I need them to add to 15x. And what's going to happen is you're going to replace the two middle terms with the two things that we're going to get here in a second. Okay? So factors of 36, we could do 2 and 18. We could do 3 and 12, which that looks like the one it's going to be. You could do 6 and 6 too. This one would give me 20. This one gives me 15. This one gives me 12. So it's this one. So we're going to put a 3x and a 12x here because that's how we get x squared. They have to both have x's on them. So now we group the first two, group the last two. So if I group the first two, I take a GCF out and I get x, and then that leaves me with 4x plus 3. GCF of the last two is 3, and I should get 4x plus 3 inside. What is on the outside becomes Wedden factors, so x plus 3 equals 0. What is shared, which should always be shared, is 4x plus 3 equals 0. So now we have factored, and we have set both factors equal to 0. I went ahead and, like, as I was writing them down, set them equal to 0 because, well, I'm lazy and I didn't want to write any more things than I needed to. So I subtracted 3 from both sides, so I get x equals negative 3. Subtract 3 on this one, so I get 4x equals negative 3. So x equals negative 3/4. And that is your answer. Okay. It's raining. I can't tell if that's thunder I keep hearing or if it's like a noise. Okay. So we have negative 3x cubed minus 5x squared minus 2x equals 0. Okay. So you should right off the bat notice they all have an x in them, which means they have a GCF. Okay. So we're going to pull that GCF out of x. So when I do that, I'm also going to pull a negative out. Okay. And that's going to allow that first term to be positive because you can't do AC method or anything like that if that first term is not negative or is positive. If it's not, it has to be positive. I'm sorry. So that leaves me with 3x squared plus 5x plus 2. So all I did was divide all of these by negative x. Okay. So I got this negative x out here, and then I'm going to try to factor this inside part. Okay, so I'm going to end up having to come back to this. So I'm trying to move this thing and it won't move. There we go. Okay, we're going to come back to it. So let's go do the AC method. So 3 times 2, oops. God, I really suck. I'm sorry. 3 times 2 gives me 6x squared. And I want to add to the middle term, which is 5. So I have 3x squared. And then the 2. So it's going to be 1 and 6, or 2 and 3, so it's 2 and 3. So plus 2x, plus 3x, and then the plus 2 out there. So I group the first two, group the last two. If I group the first two, I get an x out, so it leaves me 3x plus 2. If I group the last two, the GCF is 1, so I have to pull a 1 out, and that leaves me with 3x plus 2. So the outside piece becomes one factor, so x plus 1. And the inside piece becomes the other factor, 3x plus 2, and equals 0. And notice I still have that negative x that I started with. It got brought down to the bottom. So now I set all three factors equal 0. So negative x equals 0, x plus 1 equals 0, and 3x plus 2 equals 0. Here, if you divide by a negative, whatever, x is still 0. Like, it's not going to make a difference. Here, subtract 1, and you get x equals negative 1. Over here, you subtract 2, and then divide by 3, so you get negative 2/3. So So you have 3 answers on this. And I should have known I would get 3 answers because in my original problem, the highest power is a 3. So that should tell me how many solutions I have. When I was on this problem here, the highest power was a 2, meaning I had 2 solutions. When I was on this problem here, the highest power was a 2, meaning I should have 2 solutions. So that highest power should tell you the amount of solutions you're going to end up at the end of this. Okay? All right. So, last one that we're doing with factoring is x squared minus 9 equals 0. So if it has 2 terms, you're going to factor using difference of squares. Okay, so the square root of the first one is x. The square root of the last one is 3. So this factors into x plus 3, x minus 3. Okay, so difference of squares, square root of the first, square root of the last. So you get x plus 3, x minus 3. So we take our 2 factors and we set them equal 0. So x plus 3 equals 0, x minus 3 equals 0. So you get negative 3 and positive 3. Okay, so this problem can actually be worked a different way. Okay, so this is if I did it by factoring, but if I chose to, I could do this by using the square root property. So we're going to now talk about solving by using the square root property. Okay? So, first of all, we have to know what the square root property says. So the square root property says with x squared being isolated, so it has to be by itself, the square root property states if x squared equals k, then what you can do is you can square root both sides, and then x becomes plus or minus the square root of k. And we've done a little bit with this actually so far this year. Remember on that quiz, the very first quiz we took, we had that question where you had to isolate the square root, and a lot of you tried to like FOIL it out and then solve it that way, but you were supposed to isolate the square root, and then once the square root or that square is isolated, then you can square root both sides and clear it out. Okay, so that's what we're doing here. Okay, we're trying to get that by itself. So steps for solving these. Okay, first step is to isolate x squared. Okay, and then you're going to take the square root of both sides. And don't forget to put the plus and the minus in there on that step. And then you're going to simplify the plus or minus side. Okay, so we're going to go back to that problem I told you we could do. So x squared minus 9 equals 0. So we did it by factoring, but you could also add 9 to both sides. So that gives me x squared equals 9. Well, at this point, you can, since x squared is isolated, you can square it both sides, and we get x equals plus or minus the square root of 9. Well, the square root of 9 is 3, so x equals plus or minus 3, which is what we got when we went up to the other problem. We got x equals 3 and x equals negative 3. Okay, so we're going to do another example of that, okay? So I have 4x squared plus 1 equals 7. So my first step would be to subtract 1 from both sides, so I get 4x squared equals 6. Divide by 4, so I get x squared equals 3 over 2. Well, when I square root a fraction, you have to square root the top, square root the bottom. So this is x equals plus or minus the square root of 3 over the square root of 2. Well, if you remember correctly, you can't leave a square root of 2 on the bottom. So we have to rationalize the bottom by multiplying by the square root of 2. So on top, the square root of 3 times the square root of 2 is the square root of 6. And on the bottom, you get 2. Now, what you could have done instead of what I did, where I simplified 6 over 3 to be 3 over 2, 6 over 4 to be 3 over 2, you could have left it like this and done the square root of 6 over the square root of 4. Well, we know the square root of 4 is 2, so we could have done it that way as well. It doesn't always work that way. I like to simplify mine and then do it, but sometimes it bites me in the butt because then I could have done it an easier way. Okay. Trying to see what we have left. All right, let's try this one. So it's 3x minus 4 squared equals 15. All right, so if I'm isolating this, the first thing I have to do is take care of whatever's on the outside. So Mr. Ellis was just explaining this to me, and I thought it was really cool. It's like you have an onion, okay? And here's the inside of your onion. Here's the outside of your onion. Here's the next layer. You don't peel an onion from the inside out. So I don't deal with that 4 on the inside first, because that's on the inside of my onion, okay? I have to peel the outside layer first. Well, the outside layer is this 3, so I have to divide both sides by 3. So this gives me x minus 4 quantity squared equals 5. The next layer of the onion is the squared part. So I have to deal with that now. I square root both sides. And again, you can't go to the core yet because you still have that outer layer. Okay, so we get x minus 4 equals plus or minus the square root of 5. Now I'm in the core, so I can add this 4 over. So this gives me x equals, we're going to put that 4 out front, so it's 4 plus or minus the square root of 5. And that's your answer. All right. We have lots of stuff left. I'm so sorry. It's a long lesson, but it's a long block schedule, so hopefully this isn't too bad. Okay. So the next thing we're going to talk about is completing the square. So completing the square is used if you can't factor a trinomial. So when a quadratic equation it can't be factored or can't be solved using the square root property, then we have to use completing the square, okay? So in this method, we add or subtract terms to both sides of the equations until we have a perfect square trinomial on one side. And then we can use the square root property, okay? So here's an example, all right, of completing the square. And then once we do an example, then we'll go through and we'll talk about like the steps for completing the square, okay? So we have x squared plus 4x plus 1 equals 0. So as we do this problem, I'm going to write the rules down here for us. Okay, so our first step is to add or subtract the constant term from both sides. So add / subtract the constant from both sides. So in the equation that I gave you, okay, actually I'm going to do something really quick. I'm going to switch where I put these. So that gives me more room. I know you're like, can you just get on with this video? Sorry. Okay, so step 1 is going to be to subtract 1 from both sides. So I get x squared plus 4x plus, I'm going to leave a blank here because that's where our completing the square term is going to go, equals negative 1. Okay? So step 2 is you calculate b over 2. Okay? And then we're going to actually end up squaring it. So b over 2 squared. So off to the side over here, I'm going to do b over 2, and I'm going to square it. Okay? Well, b, remember when we're in ax squared plus bx plus c, b is this middle term here. So b is 4. So I'm taking 4 divided by 2 squared. So that's 2 squared, which is 4. Okay? And what you're going to do is add that value to both sides. So step 3, add your b over 2 squared value to both sides. So I'm adding 4 to both sides. So add 4 here and add 4 here. What we've done is we have created a perfect square trinomial on this side. And if you remember, perfect square trinomials end up factoring into like x plus 2, x plus 2. It's the same thing, okay? So we call that x plus 2 squared or whatever it's going to end up being, okay? So, but when we add something to one side of the equation, you have to add it to the other to keep the equation balanced, okay? So now you're going to factor the left side of the equation. So if I factor the left side, it's going to be a quantity squared. So the square root of the first term is x, the square root of the last term is 2, so this becomes, and there's a plus in the middle, so this is x plus 2 squared. Okay? And then negative 1 plus 4 is 3. So now your last term, or your last step, is going to be to use the the square root property to solve. So at this point, I can square root both sides. So this gives me x plus 2 equals plus or minus 3, square root of 3. Subtract 2 from both sides. So I get x equals negative 2 plus or minus the square root of 3. And you always put your solid number in front of the square root. And that is it. Okay, we're going to do another one like that because that was kind of nutso. All right, I don't really like that pink color. I'm kind of over it. Let's do purple. All right, so we have x squared plus 3x minus 5 equals 0. And they will tell you to complete the square. They'll say solve by completing the square. If it didn't tell you to solve by completing the square, you would know you would need to do that because you can't find two things that multiply to negative 5 but add to 3, okay? So the first step in completing the square is to add the 5 to both sides. But we're still going to leave a space here because we need to change our c value basically, okay? So to get our new c value, we're going to take b over 2 and we're going to square it. So my b value is 3, so I'm taking 3 over 2 squared. Okay? And if you square a fraction, it becomes 9 over 4. So you square the top, square the bottom, so we get 9 over 4. Oh, why would they do this with the fractions? That is the meanest thing that they have ever done to me. Wow. Ow. Ow. Guys, I wrote the problem down wrong. Well, we're going to stick with what we got. Okay, no, it's fine. So now we have plus 9 over 4. Okay? So this side, if we square root the first, that's x. Square root the last, well, look, over here we're taking 3/2 and we're squaring it. So if you square root what you already squared, it gets you back to where you started. So if I square root 9 over 4, I should get back to 3/2. Ooh. And then because this is a plus, I'm going to put a plus in the middle here. 5 over 4, or 5 in fourths is 20 over 4. So that gives me 29 over 4 on this side. So now I can peel my onion, so I can solve. So I square root both sides, and I get x plus 3 over 2 equals plus or minus the square root of 29 over 2, because the square root of 4 is 2. Now I'm going to solve this by subtracting 3 halves from both sides. So this gives me x equals negative 3 halves plus or minus square root of 29 over 2. If you leave it like that, that's sufficient. You can also make it one big fraction and put negative 3 plus or minus the square root of 29. I don't really care which one your answer is in. Either one would be acceptable. And that's it. That's completing the square. And if you need to like pause this video and step up, like take a break, because it's a long video, do what you gotta do. Oh no, I lost the tip to my little pencil thingy just now. Oh, so many things going wrong. All right, this is quite possibly my favorite thing to talk about because there's a song that goes with it. And I'm gonna spare you for my singing today on this video, but I am gonna play it for you when I get back on Friday. Quadratic formula. So if you remember from Algebra 2, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And you have to use the quadratic formula also when things can't be solved using any of our other quadratic thingies. Okay, so here we are. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So if I give you the problem, x squared plus 5x plus 1 equals 0, which if you remember correctly was that example we did a little bit ago. You could also solve it using the quadratic formula. So we have to know what a is. So a is your leading coefficient because this is all in the form of ax squared plus bx plus c. So a is 1, b would then be 5, and c would also be 1. So we're just going to plug them into our formula. So I get x equals negative b, well b is 5, so negative 5, plus or minus the square root of b squared, well that's going to be 5 squared, minus 4 times a, which is 1, times c, which is 1, all over 2 times 1. So you get x equals negative 5 plus or minus the square root of 25 minus 4 all over 2. Well, 25 minus 4 is 21. If you can simplify the radical, simplify the radical. I can't simplify the square root of 21. So I'm done. All right, so I'm going to use quadratic formula again. I have x squared plus x plus 2 equals 0. Using the quadratic formula, we're going to solve this. And it will tell you in the directions, use the quadratic formula to solve. Okay, so x equals negative b. Well, this is a, this is b, this is c. So a is 1, b is 1, c is 2. Wow, this one's really super exciting. So we have x equals negative 1 plus or minus the square root of b squared, so 1 squared, minus 4 times a times c, all over 2 times 1. All right, so this gives me x equals negative 1 plus or minus the square root of 1 minus 8 all over 2. So that gives you negative 1 plus or minus the square root of negative 7 over 2. Well, you should know that you cannot take the square root of a negative number. So what this is going to end up becoming is x equals, and you can't leave it like that, is negative 1 plus or minus I square roots of 7. Negative square roots of 7, or square root of negative 7 has to become I squared of 7 all over 2. If you can simplify that, simplify it, but you can't, so we're just going to leave it like that. And that's your answer. Okay, so in the quadratic formula, so I'm going to write the quadratic formula again. So you have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So this b squared minus 4ac, this is what we call the discriminant. And what you can use the discriminant to do is to be able to identify how many solutions you're going to have without having to do the quadratic formula, okay? So like on this one, if we looked at our b squared minus 4ac, we would have gotten a negative 7, so you would have known that that answer would have had 2 non-real solutions, okay? Or 2 complex solutions, okay? So there's a bunch of steps. So you might want to make sure you know that when it asks for the discriminant, that's b squared minus 4ac, okay? So there's a table on page 127 that goes through like the different values. So it says if b squared minus 4ac, so if the discriminant is equal to 0, then we have one rational solution. So one, like, remember, rational can be written as a fraction, but like 2 over 3 can also be written as a fraction, okay? So that's something that's going to have a double solution. So like if we got like x equals 2 and x equals 2 or whatever, that's a double solution, okay? If b squared minus 4ac ends up being greater than 0, then that means you have a perfect square. Oh, I'm sorry. If you have b squared minus 4ac greater than 0 and it's a perfect square, so like 16, 25, whatever, okay, you're going to have 2 rational solutions, meaning they're going to be just like normal 1/2, 1/3, 2. So x equals 2, 3, 1/2, negative 3 over 5. Okay, it could be a fraction. That's still a rational. Whole numbers are rationals, but it's just a regular old answer, okay? If you have b squared minus 4ac and it's greater than 0, but it's not a perfect square, so like 8. 8's not a perfect square, okay? Then you're going to have 2 irrational solutions, which means you're still going to have a square root somewhere in your answer. So x equals square root of 2, square root of 3, square root of 21, etc. And our last option, well, if we were comparing it to 0, then if b squared minus 4ac is less than 0, so it's negative, like we did on that other one, you're going to have 2 complex solutions, which means they're going to have imaginaries in them. So it could be like 2i, 3i, 4i square roots of 2, or, you know, whatever, okay? It's going to have an I in it, all right? So if it says use the discriminant to find the nature of the solutions, then you're going to do the following. So for A, we have a couple examples here. We have x squared plus 4x plus 4 equals 0. Okay, so our discriminant is b squared minus 4ac. Okay, so A is 1, B is 4, C is 4. So this is going to become b squared is going to be 4 squared minus 4 times a, which is 1, times c, which is 4. 4 squared is 16. 4 times 4 is 16, so 16 minus 16. All right, so we're getting 0. Okay, so you go back to your table. All right, if b squared minus 4ac is 0, we're in this form right here, okay, which means we have one rational double solution. So b is 8x squared plus 14x plus 3 equals 0. So that means a is 8, b is 14, c is 3. So b squared minus 4ac becomes 14 squared minus 4 times 8 times 3. So 14 squared is 196. 4 times 8 times 3 is 96. So that's going to leave me with 100. Okay, well, 100 is a perfect square. Okay, so if 100 is a perfect square, then if you go back to your table, if it's bigger than 0, which it is, but it's a perfect square, then you're now in this one, which means we have two rational solutions. So 2 rational solutions. And for time's sake, I'm not going to do the last two, but they are in the book on page 127 if you want to see them. All right, last thing is we're going to do the Pythagorean theorem. And I know you guys love the Pythagorean theorem so much. Pythagorean theorem. And if you've ever seen The Wizard of Oz, the Tin Man actually messes up the Pythagorean theorem, in case you wondered. So it says in a right triangle, and it has to be a right triangle, not just any triangle, a squared plus b squared equals c squared. Okay? Oh my gosh, it's pouring, and I'm going to have to leave as soon as this video is over. I'm going to be really sad. So our example says find the length of the missing side in the right triangle. Okay, so they give me this picture, and the picture they give us looks way better than the one I just drew. They tell us it's a right angle. They said this is 4, this is 12, and this is A. And you have to know, you have to know, okay, they called it A, but that doesn't necessarily mean that's like A squared, okay? You have to know that your hypotenuse, which is always your C value, so C is your hypotenuse. C is always, that says hypotenuse, not use. I don't know what I did there. Is always opposite your 90-degree angle. So 12 is my C value automatically. Okay, that has to be C. And the other two, it doesn't matter. So I can do A squared plus 4 squared equals 12 squared. So that's A squared plus 16 equals 144. Subtract 16 from both sides. So that gives me A squared equals 128. We can square root both sides. So I get A equals plus or minus the square root of 128. Well, the square root of 128 has 64 in it. 64 and 2. So A becomes plus or minus 8 square roots of 2. And that is the lesson in all its entirety, okay? So, I'm sorry that was so stinking long. This is, your homework is page 129. You are going to do 1 through 43 and 54 through 58, and I hope you, I hope that's not too much. I'm sorry if it is. Okay, you need to skip, if it says technology, if it tells you to use your calculator, go ahead and skip that. We're going to have a day, probably Friday, where we go through, or maybe Monday, where we go through and we talk about how to do some of this stuff with the calculator. But that means that all of you need to get a graphing calculator so that we can do some graphing. All right, have a great day.